It's Miss B again. Today we're going to be working with factoring trinomials when the leading coefficient is not 1. Today the ones we're going to work with don't have a greatest common factor. So that will be the next video that we do. So this is an Algebra 1 video. If you're pre-algebra and you want to look at it, get ahead of it, awesome. But what we're going to work with today is we're going to work with factoring trinomials, which means we're breaking them into the two pieces that made it, okay? But we're going to do it where it starts with something besides x squared. It starts with 2x squared, 3x squared, 5x squared, something just a little different than what we did in the last video. Now, a lot of our basic mechanics are still the same. There's one little add-on that changes how we pull our factors, but it's not a big deal. So let's just look at it. We'll take it step by step, okay? Get set up to show you my pad here. Okay. So here we go. Now, we've talked about it before. The first thing we're going to check for is for the GCF. Does it have one? In this case, all the ones we're going to work with don't. So the next step is to identify your A, B, and C. Well, what do I mean by A, B, and C? The standard form for a trinomial is ax squared plus bx plus c. Now, and if we're solving it for its roots, which is something we're going to talk about later, it equals 0. But we're not worried so much about this as we are this. Okay? The next thing we're going to do is we're going to multiply the first and the last term together. Okay? So that means if my example is 2x squared plus 5x plus 3, the first thing I want to do is say, what is 2 times 3? Well, 2 times 3 is 6. Okay. Now, why is this 6 important? We have to find factors of 6 that add up to or subtract to the result. Actually, not to the result, to what? They have to add or subtract to b. So I need two numbers that multiply to 6, but add or subtract to 5. Well, 6 is either 1 times 6 or 2 times 3. Well, because this is a plus and this is a plus, we're looking for things that add together. So is 1 plus 6? No, that's 7. So 2 plus 3 is 5. That's what we're going to use. Now, we're going to take this 2 in with 3, and we're going to split this x into its components. So now I have 2x squared plus 2x plus 3x plus 3. Now, we look for pieces they have in common. So we're going to find common factors. And we're going to do this 2 pieces at a time. So first of all, I'm going to look here. Okay, 2x squared and 2x. What do they have in common? Well, if I write it out, just what it means by factors, I've got 2 times x plus 2 times x. Well, both of them have a 2. Both of them have an x. Well, what's left? Well, let's write that down. I have an x in the first one, and here, if everything divides out, I have a 1 left behind. Same idea in the next half with these two. 3x plus 3. Well, both of them have a 3. If I take that out, what do I have left behind? have x plus 1. Now, let's look at this again. What does the first half and the last half have in common? They have x plus 1 in common. So if I take that out, what do I have left behind? I have 2x plus 3. Now, do I have a binomial times a binomial then? Yes, and I can go through and I could do my FOIL and I could check it, and I'll find out that the quantity x plus 1 times the quantity 2x plus 3 gives me 2x squared plus 5x plus 3. Now this will work for anything as long as you've made sure to take out the GCF. Okay, so let's look at another example. 5m squared minus 17m plus 6. So do we have a GCF here? Let's look. 5, 17, and 6. There is nothing that any of those have in common. So now I'm going to do 5 times 6. Well, 5 times 6 is 30. Now, I have a minus here and a plus here. If it's a plus in front of the last term, plus in front of the C, when I end up with this, both pieces are going to have to be negative. It's one of those math things. So I'm going to put myself a reminder up here. Both my pieces need to be negative. Now, numbers that multiply together to give me 30. Let's see. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Well, I've made my note up here that both of these have to be negative. Okay. So now let's look. Negative 1 minus 30 is negative 31. That's not what I need. Negative 2 minus 15 gives me negative 17. That's what I'm looking for. So this is what I'm going to deal with. I'm going to break negative 17m into negative 15m and negative 2m. And then I'm going to write down the other stuff that was there. Now, why did I choose to put negative 15 first and negative 2 second? Well, if you look at it, 5 and 15 are both multiples of 5. That means I can take a 5 and an m out of this and leave me with m minus 3. Negative 2 and 6 are both even numbers, which means they can both be divided by 2. But since this is a negative 2 right here, I'm going to take out a negative 2. That's going to leave me with m minus 3. Now, how did I get this minus 3? If I say 6 divided by negative 2, my answer has to be negative 3, because a positive divided by a negative is a negative. Now let's look at this statement. 5m times m minus 3 minus 2 times m minus 3. Right here, I have something in common that I can take out. So I have m minus 3, and what I have left is 5m minus 2. So we're following the same procedure every time. Our numbers change a little, but our procedures don't. Let's look at another example or two. So our next one will be 6y squared plus 3y, oops, sorry, minus 5y, looking at the wrong line, minus 4. Now, does this have a greatest common factor? Well, let's look. 6, 5, and 4. None of those numbers can be divided by the same number. So we're good with no GCF. 6 times 4. Well, 6 times 4 is 24. Okay. Now, both these pieces are negative. If both of these pieces are negative, then when I multiply, and you look here, 6 times negative 4. So is this positive 24 or negative 24? It's actually negative 24. And when I'm looking for this 5 in the middle, it's a negative 5. So one of my pieces has to be positive. One of my pieces has to be negative. Now, let's go to 24. 24 is 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. Okay. Now, if I'm adding or subtracting, and I want to get a negative as my answer, either both pieces have to be negative, or you have one of each, you're subtracting, and the bigger one gets the negative because the answer has the negative. So I'm going to go through and I'm going to put a minus with all my big numbers. And I need to find negative 5. 1 minus 24, negative 23, not going to work. 2 minus 12, negative 10. Closer, but not what I want. 3 minus 8, negative 5. There's the one I want. So now I'm going to break this apart. I'm going to break my negative 5y apart. So I have 6y squared plus 3y minus 8y minus 4. Okay, if I'm looking at the first two pieces, do they have anything in common? Well, 6 and 3 can both be divided by 3. I got a y here and a y here, so I can take one of those out. 6y squared divided by 3y leaves a 2 and a y behind. 3y divided by 3y is 1, because we're talking about a number divided by itself. So let's look at the next part. Negative 8y minus 4. Well, isn't 8 2 times 4? That means I can divide out the 4. And I'm going to divide out a negative 4 because both those pieces happen to be negative. So let's do this. Negative 8y divided by negative 4 gives me 2y. Negative 4 divided by negative 4 gives me 1. Do they have anything in common? They sure do. They have 2y plus 1 in common. Take that out, write down what's left. Okay. Once again, we have taken our number and factored it. Taken our trinomial and factored it. Okay. So now we have, last example, 12c squared plus 11c minus 5. Okay. I'm going to give you all a minute or so to look over this before I start working it. I want you to take a second, pause the video, see for how far you can get based on what we've already done before you start the video again. Can you get this factored all the way to the end before you start the video again? I'm going to give it about a minute before I start talking again, but now would be a great time to pause the video and try this for yourself. Okay, now let's look. Does it have a GCF? Can each of these numbers be divided by the same number? No, they can't. So now we go to first number times last number. 12 times negative 5 gives me negative 60. Now, plus in the center, minus on the end, means that I have to have one of each. Okay. Numbers that multiply together give me 60. 1 and 60, 2 and 30, 3 and 10, 4 and 15, 5 and 12, yeah, 5 and 12, and 6 and 10. Now, which one is going to give me what I need? Well, first of all, I need to know which ones are positive and which ones are negative. Well, if I'm looking to get an 11C at the end, that means the bigger number when I do this has to be the negative. No, it doesn't. It means it has to be the positive. I am so sorry. Okay, so the bigger number has to be the positive. So I'm going to go through and I'll make my smaller number the negative every time. Now, -1 plus 60 is 59. -2 plus 30 is 28. -3 plus 10, oh, that's not supposed to be 10, that's supposed to be 20. Let's try that again. -3 plus 20 is 17. That's closer, but that's not what I want. -4 plus 15 is 11. There we go, that's what I want. So now I'm going to break this 11 apart. So I have 12c squared minus 4c plus 15c minus 5. Now we start looking for things that they have in common in smaller chunks. Take the first two pieces. 12 and 4. Both of those numbers can be divided by 4, so I'm going to take out a 4. I have a c squared and a c, so I can take out a c. 12c squared divided by 4c leaves me 3c. -4c divided by 4c leaves me with -1. Now I have 15c minus 5. Well, 15 and 5 are both multiples of 5. So I can divide each piece by 5. 15c divided by 5 is 3c. -5 divided by 5 is -1. Now let's look at this. 3c minus 1 here, 3c minus 1 here. They can be taken out, and then I write down what's left behind. Every single time, if you follow step by step, you should be able to factor these. I'm going to put 2 more examples on the page. Well, actually, I'm going to put 1 at a time down because I'm going to run out of room on my page. So let's take this one first. 3g squared minus 7g plus 2. I'm going to let it go for about a minute. What I want you to do is I want you to pause the video, work this for yourself. When you get finished, start the video again. Check your work against mine. I'm going to give about 30 seconds to a minute of the video to give you a chance to pause it and get started. Okay, let's look at this. Now that you finished it and unpause the video, let's look at what we did. 3, 7, and 2. None of them can all be divided by the same thing. So now I've got to do 3 times 2 is 6. All right. So we got that right, okay? Now, minus in the middle, plus on the end, means both pieces have to be negative in our answer. But I need numbers that multiply together to give me 6 and add together to give me -7. So 6 is either 1 times 6 or 2 times 3. And because this is negative and this is positive, both my pieces I'm dealing with, both my factors are negative. Well, -1 minus 6 is -7. So that's what I need to use. Now, when I put this in my problem and I break up my -7g, 6 and 3 can both be divided by 3, so I'm actually going to put them together. 3g squared minus 6g minus 1g plus 2. Now, did I have to put the 1 with that? I don't. But to help kind of my brain process things, I'm going to leave it in. Okay, now 3g squared and 6g can both be divided by 3 and g. So now let's go. 3g squared divided by 3g is g. -6g divided by 3g is -2. So that part's taken care of. Look at this other part. The only thing that I could divide 1 and 2 by, and it'd be the same thing as 1. But because I have a g minus 2 here, and I have a -1 here, I'm going to divide by -1 so I can change the signs of everything in here. -1g becomes g, and -2 becomes +2. Is that right? Did I do that right? Hang on a minute. I've got something bothering me here, guys. Give me just a second. Okay, let me look at this. What did I do wrong? Okay, make sure I copied it right first. Okay. Now let's look. 3 times 2 is 6. 1 and 6 is 7. Okay. I take out 1. Wait a minute. Oh, right here. See what I did? I found my mistake. I did -2 divided by, +2 divided by -1. So should this be a +2 or a -2? This should be a -2. Now, see why knowing positives and negatives is important. Even math teachers get stuck with it. So now let's look. I have a g minus 2 here and a g minus 2 here. So I can take those out. And I'm left with 3g minus 1. Now, I'm going to give you one more to do on your own. I'm not going to tell you the answer. If you watch this video and you're my current student and you think you get the answer, you know how to email me with your answer. Otherwise, you can put it in the comments. Tell me if you think you got the last one right. All I'm going to do is I'm going to give you the problem. I want you, once you find the answer, to put it in the comments. So here we go. 3c squared plus 2c minus 16. So there's your challenge. Factor this one and either email me or put in the comments what you think the answer is. Good luck. Use your examples. Take your time. And I'll see you next time.